So we're here at CeBIT 2009.
Right.
And can you introduce yourself where we are right now?
Right. Okay, so my name is Paul Kröger. I'm a professor for autonomous systems at a university in Germany, in St. Augustine. And we have been in a common project to build such a robot. The robot which you see is a certain type of robot which is called service robot. So the aim is to assist human beings in their daily jobs or tasks, let's say. That's the reason why the robot in principle is looking so humanoid in some sense. So it has 2 arms, it has 2 hands. The hands have 4 fingers, not 5, but 4 is well enough, I think. And as you see here, the task of the robot should be to arrange these objects into the 2 bags, left-handed or right-handed bag, depending on the category of the object. So what's the problem with this? The problem with this is that such a robot has to have many abilities to be able to perform these jobs. So we can guess some of these abilities looking at the robot. And we have 2 eyes, which provide stereo vision. So objects we have an in-depth field. So the robot can really spot the objects in distance and direction. In the middle we find a special sensor which is called CSEM, which is a Swiss sensor. It's a single camera which can already provide a depth in field picture. So it's a quite fancy sensor.
What do you mean about the CSEM? Is that new technology?
It's a sort of new technology.
Yeah.
It has been around for a couple of years.
How does it work?
It works by, well, this is an interesting story, let's say.
Yeah.
So it's a traditional camera, but the light being emitted, so there is light around,
yeah.
There are LEDs around, and there is light being emitted. And this light has a certain phase. And the photoreceptive sensors inside the object, inside the lens,
yeah.
they look at this scenery 4 times, and by comparing the phases of the reflected light, they get this depth and field information. So it's not just like a regular camera, but you have four pictures on top of each other, and by comparing the phase distribution of the emitted light with respect to the distance of the objects, you can compare. By comparing, you know the depth of the object.
But why do you need both systems, where you both have both eyes and the new CSEM?
Right. So these two lenses, the traditional lenses, are not only used for depth and field information, but they can also do people recognition. So you do face identification. Okay. And the face identification needs a regular optics. I mean, there's no way. I mean, there's no way out. Yeah. This one, although it is fancy, I agree, but it is very noisy. So the picture by itself is fine. I mean, you have an intensity picture, black and white, and the overlaid distance information is sort of crumped, really a little shaky, let's say. And as such, you have to compensate this noise by the traditional stereo vision.
Do you think that CSEM will be embedded in mobile phone cameras at one point?
For sure, yes.
It's possible?
I think so. Yeah, that's possible.
Yeah?
It's just a matter of the process. Since it's a silicon-driven process, it's a single sensor. So it's mainly the question of how can you mass produce this technology, and by doing mass production of it, you can make it arbitrarily cheap.
Yeah. Does it only take one point, or can it recognize like 3D somehow and generate 3D images and stuff like that?
It can in fact recognize 3D images. Yeah? Yes. So depth and field information are really available from this camera.
If you took a picture with that kind of sensor, then you could generate 3D objects with the camera, normal camera.
So for example, in principle, if you do investigations or crime investigations, let's say, so you want to, let's say, have a witness of the surroundings of this victim or whatever. In principle, you can think of a device, you just scan the whole environment with a handheld camera, and you freeze the whole environment and can reconstruct everything at home in your lab or in where the investigation is going on. So this is it's possible.
It needs a lot of processing power to do that?
It needs processing power, that's true.
So for now it's not in a mobile phone?
It's not in a mobile phone right now. There's no chance, no.
So you need a grid server somewhere behind and
not a grid. A regular PC would do right now. But I mean, of course, this is a matter of time to shrink, wrap it into a mobile phone.
So do you think that the next Mars mission will use that kind of camera for...
Mars mission? No, I don't think Mars mission will do this.
They don't need that?
They need it, but this is too far ahead. The next Mars mission would be, let's say, 5 years.
Okay.
But to make this technology robust, as much robust as is needed on the Mars, we need more than 5 years.
Oh, more than 5, okay.
Yes.
Right.
And the robustness is the point, not to make it operative from a principal point of view. This is working already, but to make it robust, this is a real big problem. By the way, this is already also a problem. Robustness is a general problem in robotics right now. This kind of robotics, not in the traditional robotics which you find in factories. This robotics is quite robust already. But in the household, robustness is a number one requirement, and this number one requirement is not well addressed enough up to now. It's still open to research. So all these perception which is going on, especially vision. Well, I mean, for example, you can see here, like these shadows. They look quite harmless for us. But for the robot, if the robot does the scene analysis, the edges which you see, they can be intermixed with the true edges of the object. Yeah? So this is a big problem. Or there's another thing which you do not recognize at all, being a human being. This light is pulsed, so it's actually going on flashing all the time. And this camera will recognize the flashing all the time. So in fact it gets some pictures very well exposed, and some of them are underexposed because the lights are out. You don't recognize this being a human being, but the robot recognizes this. So these are the kind of problems which you face. Or for example, the mixture between daylight and artificial light. The temperature of the light is completely different. And as such, the camera has to adapt to this process of different light reception. And all this is a real hassle, and all this is a real problem, because in industrial robotics, all conditions are confined to the robot's abilities. So you build the environment to make it fit to the abilities of the robot. But here, doing everyday robotics, it's the other way around. We have to fit the robot to the conditions of everyday life. So we go exactly the other way around. And that's the difference between industrial kind of robotics and surface robotics.
Thanks.
Welcome.